So now we're going to finish up classwork 5.8. So tell me, do you feel odd or even or neither today? Because it just makes it more enjoyable to at least do more than just math. Do you feel odd, even? You feel even? All right. What do you guys feel? Even, odd, or neither? What do you feel today? Okay. No one wants to respond, but think in your head, how do I feel? Why? I don't know. Just to do something besides just math all day. Oh, you are here. Let me put that in attendance. I remember that you're number 1. Okay, letter E. We're trying to figure out even, odd, or neither. With polynomials, if all the exponents are even, you are allowed to have a lone constant term, meaning you're adding or subtracting a number. That is allowed, and you are still having an even function. However, if the 6 and the 2 exponents were both odd numbers, having this extra subtraction of 5 would force it to be in neither if those were odds. Only even allows you to do an addition or subtraction, because if you vertically move, you're still symmetric to the y-axis. Letter F is looking at a graph. Is that symmetric over the y-axis? Your answer is yes. It is symmetric over the y-axis. That means that is an even function. Now I'm coming back to some tables. With the tables, you want to look at opposite signed x values. So for the 2, -2 pair, the y value that goes with them are opposite signed from each other. So because this is negative and this is positive, right now, this is either an odd function or it's neither. So most likely odd. Then we've got to look at all the information in the table. And I'm not giving you tables any bigger than what you see here. -1 and +1 are opposite signed x's. Look at those y values. Are those y values themselves opposite signed? One of them is negative, one of them is positive. Yes, they are. Still up for the odd. But now look at the center, 0. Is this odd or is this neither? To be odd, an odd function is additionally, the symmetry is called origin symmetry. And that helps to emphasize the fact that it has to go through the origin if it is defined at 0. Do you see that it has a y-intercept of 5? If it has a y-intercept of anything other than 0, it is not allowed to be in the odd category. Odd functions, let's look at the graphs of the odd functions. A graph of an odd function has to go through the origin, or this one is an odd function. It doesn't go through the origin, but it also doesn't have a y-intercept at all. So odd functions are either have a y-intercept of 0 or they have no y-intercept at all. So that one is a tricky issue of neither. It's not obvious that it's neither. You have to look at the odd tables very carefully. Here's another table. I have opposite signed x values. Their y's are opposite signed. One's negative, one's positive. Another pair of opposite signed x's, look at their y values, are the y values that they have opposite signed. One is positive 8, the other is negative 8. So yes. 0 is undefined. So is this odd, even, or neither? So if it has opposite signs and not 0, 0. Okay, if it has opposite signs, then it's only able to be odd if it has one of two things. Either it has 0, 0 or 0 undefined. And let me show again, this odd graph goes through 0, 0. The odd graph of 1 over x, this is an odd function, but it is undefined at x equals 0. It doesn't have a y-intercept. So one way you could look at it is either it has y-intercept 0 or no y-intercept at all, if it's going to be odd. So I'm hoping that helps you out with that issue. And then I've got another table. And I have opposite signed x's, same exact y value. So now we're up for this could be a neither situation, or not a neither, I'm sorry, an even is what I meant to say. Opposite signed x's, do they have the same y's? Yes. When it comes to an even function, it doesn't matter what happens at 0. 0 could be anything, including undefined. It does not matter. So this one is even. And I want to show you an even graph where it's undefined at 0. This one right here, actually. This is a graph that is undefined. There is, for the y-axis, there's no y-intercept, but it is an even function. So here's the bottom line. With an odd function, it matters what happens at 0. For an even function, it does not matter what happens at 0 at all. For an odd function, it has to either have a y-intercept of 0 and not have a y-intercept for something that is not 0, or it is undefined at 0. One or the other. All right, now, before I hit the next 3 problems, I want to finally go back to something that I told you we'd go back to. So we looked at number 5 with determining even or odd with polynomial equations. With polynomial equations, it's even if all the exponents are even, but it can include a non-zero constant, that's okay. Odd if all the exponents are odd, but there cannot be a constant. If you have any mixture of even and odd exponents, it's neither. Or if you have something that was having all odd exponents, but there is a constant term, like we see right here, with that constant term, it falls into the neither category. To fall in the odd category, it cannot have that constant term. Now, what about rational functions? Rational functions are a polynomial over a polynomial. Now, when you're dealing with an even function, if you replace all the x's with negative x's and you actually get the same exact function, then it's even. So I want to point out to you that you have a numerator polynomial and a denominator polynomial. If both polynomials are even, there won't be any sign changes on the fraction itself. But if they are both odd, if you have an odd degree polynomial over another odd degree polynomial, that causes, when you plug in the opposite x, your numerator changes sign and your denominator changes sign. If both of them change sign, they basically undo the other's problem. If they are both odd, you end up getting, so if you have, let me just say f of x over g of x. If you have that you plug in negative x into both numerator and denominator polynomial, if they are both odd functions, they both have an extra negative as the simplification or the equivalent to putting in the negative number. Those two negatives take each other out. So that's a rule to live by. Odd, in order to get an odd rational function between the numerator and denominator, one of them has to be even and the other has to be odd. Because if either numerator changes sign or denominator changes sign, the whole fraction changes sign. And you're going to get a neither situation if either the numerator or the denominator, one, both, it doesn't matter. If either of the two polynomials are a neither, the fraction is a neither. And now we're going to look at some examples. And that's what J, K, and L are here for. So let's start with J. For the numerator polynomial, is that an even or an odd function? Or neither? It is odd. That polynomial is odd. What about the denominator polynomial? Is the denominator polynomial even or odd? Yes. What does that mean about the entire function? Even. And I feel like I need to show you a Desmos graph just so you can see this a little bit more. And I need to remind myself that was x over x cubed minus x. And we have been working with rational functions. So there's some things I want to point out to you that we know about what this graph should look like. Do you see the numerator degree is less than denominator degree? If that happens, the horizontal asymptote is 0. Now, this one has an issue that I would not ask you to deal with in your personal graphing. And that is that this actually simplifies, because if I factor an x out of the denominator, this actually simplifies to 1 divided by x squared minus 1. It's the same exact thing. The only difference is that this function, if I look at the red one, at 0, whoop, there it is. 0 is undefined for the red graph because we cannot have a divided by 0. For the blue graph, 0 is defined. That is literally the only difference between these two. Now, looking at this second one, the blue graph, do you see what makes the denominator 0? Positive 1 and negative 1, right? Those are vertical asymptotes of this graph. And actually, after I simplified, do you see that the denominator is now an even degree polynomial? Isn't that interesting? And a lone constant, by the way, if you have a lone constant, so in other words, if you just have the function y equals 1, I want you to look at that. Does that have symmetry to the y-axis? This line right here. Is this symmetric to the y-axis? Or is the y-axis a line of symmetry? The y-axis is a line of symmetry. Whenever you have just a constant, it has y-axis symmetry. And actually, it's considered an even degree polynomial. And I'm just going to say why for those of you who are planning on doing more math. The rest of you, you don't have to worry about this so much. If I have just y equals 1, technically that's 1 times x to the 0 power, and 0 is considered an even number. So constants by themselves are polynomials that are even. So after we simplified by factoring out an x and canceling, we end up with something that has an even over an even, which is that other even situation. So this was a really nice problem to take a look at that. So overall, even. All right, next, letter K. Numerator polynomial, is that even or odd? Just the numerator. Is that an, that's an even. Denominator polynomial, is that even or odd? Or neither? The denominator. Look at that denominator really carefully. For the first term, you have an understood 1 exponent. That puts it in the odd category. But can odd have a minus 1 constant? It can't. So that denominator polynomial is neither. If one of the two polynomials is neither, we've got neither. And then actually this just goes into what I was describing a moment ago of if your polynomial is just a constant, is that considered odd, even, or neither? Let's see if you remember. Just a constant. It's a polynomial. Is it even or is it odd or is it neither? And I see some looks that say I know what the answer is. And hopefully online you are seeing if it's just a constant that is considered even, it has y-axis symmetry. The denominator, is it even, odd, or neither? I've got an even exponent and a constant. So actually, for in class, is it even, odd, or neither? So show me one, even, odd, neither. Good, good, good. It's even. It's allowed to have a constant added or subtracted to it. So an even divided by an even is even. And I'm going to skip over to letter P because that's another rational equation. And let's do that one. Numerator polynomial. Is it even, is it odd, or is it neither? What do you think? That numerator polynomial, even, odd, or neither? It's odd. I have an exponent 3 and an understood exponent 1. Those are both odd exponents. I have no constant added with my numerator. It is odd. For the denominator, is that even, odd, or neither? Even, odd, or neither? And let me get back to that last question in just a second online. Is that denominator polynomial even, odd, or neither? Even. It has an even exponent and a constant is considered an even term, so it is even. Now, the question I see, I think the issue that you're confused on is within one single polynomial, all the terms that are adding, they have to be either all odd or all even. But when you're looking at a rational function and two polynomials, you have to first look at the individual polynomials and then look at the whole fraction over all. So then, or is it that only? Did that help? Because the two odds thing is if the numerator polynomial is odd and the denominator polynomial is odd, then the whole entire fraction is even.
Yeah, that's what I was confused about. I thought it
Yeah.
had two odds in the numerator, but that also just makes it even. But that's only true if you have an odd on top and an odd on the bottom, right?
Right. Yeah.
Okay.
Yeah.
And if you have one part that's like even and one part that's odd, like either on the top or on the bottom, is it neither?
If you're dealing with a polynomial, if you're adding together terms where one of them has an odd exponent, one of them has an even exponent, that's going to turn into a neither. Only the polynomials can come up as neither, and if one of the polynomials comes up as neither, that's the only way for the whole rational function to be neither. The full rational function will only be a neither if one of the two polynomials shows up as a neither. And then within the polynomials, either all exponents are odd or all exponents are even, with that one tiny little exceptional issue of You can't have a constant added on with an odd. You have to look at constants as even terms. So this is showing an odd term. This is showing an even term. This is an even term. If I'm adding or subtracting, I can't add odds and evens and get something that is special. If I add odd and even terms, I'm going to get a neither situation. Over here with the rational function, I'm looking at if I have two polynomials and both of them have either an even or an odd going on, then I can have a rational function that is also either an even or an odd. And it's a lot to take in, but just kind of look back at this later if you need to remind yourself. The polynomials alone have a way to determine even and odd. So there's a way to determine if a polynomial is even or odd. And the easiest way to say it is it's even if all the exponents are even, it's odd if all the exponents are odd, and it's neither if there's a mixture of even and odd exponents. The only thing that throws that narrative off is the constant. If there's a constant added on, it doesn't work with the odd situation. That's the only exception to the rule of even exponents only, even function. Odd exponents only, odd function. Then when you go to the rational function, you have to determine even or odd for numerator, even or odd for denominator. If one of the polynomials, or both, you're only going to get neither if you come up with one or both polynomials being neither. But if you get that both of your numerator and your denominator come up even or odd, then both even or both odd give you even, because it's a negative divided by a negative goes back to positive. But one even and one odd is dealing with a division of a negative and a positive, and that always comes up negative. And that is exactly why the even and odd goes with that information. So hopefully that clears it up. And now I have just a little bit more to go. And these M and N are actually more challenging problems. When you have a square root graph, do you remember the parent function is half a parabola? This function has a restricted domain. The only way to get an even or an odd function is if the domain is also symmetric to the y-axis. I can't have a domain where one side goes to infinity and the other side doesn't. If you think about the parent graph of this, do you see that a square root function is never going to show up as even or odd? It doesn't have the symmetry to begin with. And there's nothing you can do to a root function to make it have symmetry. So this one is a neither, and I'm going to go with that explanation. I'm not going to test you on a problem like this. This one is a bit brutal. So let me start off with saying this factor is an even polynomial. Now there's a difference between a singular polynomial and I'm looking at the addition of terms or the subtraction of terms. When we talked about even and odd for rational functions, that was dealing with division of functions who are either even or odd. I can actually look at individual factors if I am in a factored form. The first factor is an even polynomial. Mm-hmm. That's okay.
So this would be considered just polynomial. So this would be considered a polynomial equation, whereas a fraction would be considered a rational equation.
Yes. Mm-hmm. Yeah. Okay. This one, though, honestly, I think this letter N is more of an honors problem. So I'm not going to test you on this issue because the easiest way to see this is if you multiply those two polynomials that I just underlined, those multiply to x squared minus 25. Do you see that? You can notice that this is an even times an even polynomial. I want to point out to you that in the classwork, oh, did I show it in the classwork? No, I didn't show it in the classwork. Okay. That is the easiest way to recognize that this is even. The long way of testing even versus odd, and I just want to expose you to this. If you're planning on going into intro to calculus or heading in that direction, pay attention right now. Otherwise, this isn't an issue for you to worry about. If I replace every x with a negative x, I can simplify and see what happens. And let me point out negative x where there was an x, and I need that parentheses. X replaced with negative x, x replaced with negative x. Now, if I simplify, if I square a negative, I force it positive. So I want to make sure to clarify this and this are identical. This turns into a multiplication. I can factor a negative 1 out of it, and it becomes x plus 5. For my next factor, I can also multiply a negative 1 out of that, and that's going to give me x minus 5. Negative 1 times negative 1 gives me positive 1. And the only difference between f of x and what I have now is the order of multiplication. So what I'm going to do is just quickly reorder these two. And you can see that f of x is equal to f of negative x. And that makes an even function. But you have to go through this simplification process if you're dealing with a harder problem like this. Okay, that concludes even and odd. I will stop the recording.